So good afternoon, everyone. I think I have an exciting talk to move the world of malware, anti-malware, from where it is today to the next generation of anti-malware, which we are working on and have released with Windows 10. Malware authors have an asymmetric advantage. Let me repeat that. Malware authors have an asymmetric advantage over us, defenders like us. They just need to find one vulnerability versus us, we need to defend against every single vulnerability. We need to block every single link in that chain. So malware authors have an asymmetric advantage. It goes beyond that. They obtain the blueprints to our products the moment they're released. They test against our products, against anti-malware products, and they're able to evade our products. This is the current state. They know that the industry reaction time is about 8 hours. So they know that if they bypass an anti-malware product, the industry will react in about 8 hours. So what did they do? So they actually shortened their time to life and their release cycle to be less than 8 hours. This is how they are getting past the existing anti-malware products. Sun Tzu, in her book, The Art of War, has a great quote. She says, if you know yourself and you know your enemy, you need not fear the results of 100 battles. Today, malware authors need not fear the result of fighting with the current generation anti-malware products. They know our products. They get our blueprints. They can bypass us. This is problem number one with the anti-malware industry today. Malware authors have an asymmetric advantage. I'll go through two more problems, and then we'll get to see how next generation anti-malware can combat this. So to counter the current industry, we released multiple security products. We call this defense in depth, etc. So there's an endpoint security product. There's an edge, web, firewall security product, email security product, mobile security product, server security product. It keeps coming out, right? And these don't interact with each other. How many of you tell me, if an alert was raised by your email security product, was that actually consumed by your endpoint security product? Not really. I see people shaking their heads. No. I mean, why, right? Why isn't this happening today? So I'll give an example. So a user goes to a trusted website, unexploited trusted web URL. Yeah, the endpoint security product can pay less attention to the file downloaded from that URL. Similarly, but if a user goes to a medium rep URL, a URL with sort of suspicious, the anti-malware product should pay more attention to that file downloaded from the URL. It doesn't happen today. It doesn't happen today because the operating system does not expose rich local context for this information to be exchanged and stored and used by these different products. This is problem number two with the industry. So, great. So we have all these products. How many of you have to manage these products? And how many of you do look at all these logs and all of you, right? And they all output verbose logs, and some of them are understandable, some of them are less understandable. It's painful. Really painful. Security products today are not optimized for the enterprise. Security products today are not optimized for the enterprise. They are good products and defend against threats, but they're not optimized. They do not make your jobs easier. And that is problem number 3. Security products are not optimized for the enterprise. Let me summarize. The current state, malware authors have an asymmetric advantage. The operating system does not expose rich local context, and security products are not optimized for the enterprise. Good afternoon. I'm Deepak. I'm on the Windows Defender team in Microsoft, and I want to show an exciting future state that we will get to and show how we're getting there with Windows Defender on Windows 10. Who's with me? Who wants to see this exciting future state? All right, yeah. All right. So we think a future state will be where the security products use and consume this rich local context. Remember that example that I mentioned earlier, where a medium rep URL file comes in from a medium rep URL, the endpoint product scans that file at a higher risk, marks that file as a higher risk, and is able to scan it more. And as that file gains more privileges, it scans it more. This is the future where security products use this rich local context to do the right scanning based on the risk level. Second, to combat the advantage that malware authors have, the asymmetric advantage. Remember the 8-hour timeline that I mentioned? In the future, we think security products will have an extensive global sensors, will be able to know what happens on every single machine instantaneously. It's not the future. It is, we can do that with Windows 10, and I'll show you how in this talk. And finally, we think security products need to be optimized for the enterprise. We need to make your jobs easier. We have done vast amounts of investment to make your jobs easier. And let's go through this. So we've taken a 3-pronged approach. Number 1, Windows 10 securely provides local context to Defender and any other AV product. Windows 10, Windows Defender is being enriched with extensive global sensors, and I'll show you what these sensors are and what type of information Windows Defender is enriched with. And finally, Windows 10 and Windows Defender is optimized for the enterprise. We'll look at each of these different legs of this strategy. So first, Windows 10 provides rich local context. So while Windows 10 provides this rich local context, the endpoint security product should also consume this rich local context. So Windows Defender picks up this rich local context and persists it and uses it in its detection. So consider this scenario. Your VP has just come back from the boardroom. They have said, hey, you know what? The situation is really bad. Our team performance, our productivity has sunk. And so she's actually come back to her office, and she's looking at her email. She's a little flustered. And in comes this mail, which says, hey, improve your team productivity tenfold. Great, she says, very timely. And let me actually open this and run this application. Who's going to resist, right? This is a great example of a spear phishing attack. This is what happens today. They know when to send these messages and how to structure these messages. So consider this example. So the email comes in. She opens the attachment. She says, let me save this. now the operating system actually says that this file arrived via email. Defender stores this information. At any point later in time, say several days later when she starts running this file and the application runs, Windows Defender is able to know that this file originally came from email and scans it at a little higher intensity. Now the process runs for a little while, and then it asks for admin rights. If it asks for admin rights, it's possibly now able to do more dangerous operations. So Defender scans this open running process at even higher intensity. And at this point in time, because the process is actually running and the entire memory is unpacked, it can detect behaviors and it can detect the malware, if it were malware, without the protections that the malware typically tends to build in. Because once it's unpacked in memory, it has already been de-obfuscated. So let's actually look at a demo here. I think it's pretty exciting, this demo here. All right, so file comes in, and she double-clicks, runs it. So right now the process is running, right? And she says, great, I really want this 10-fold productivity increase, continues, and yeah, you know what, now it requires admin rights. Let me actually go ahead and do it. So thinks about it, UAC prompts, she says, yes, I really need it. Whoa, wait a second, actually ran. Oh, hold on, she was running Windows 7. No way. that's the current generation. Let's move on from there. Let's look at what it is today with Windows 10. It's the same file. So admin rights. And at that time, Defender scans it. Yeah, sorry, I tried to play around with the with the screen size, but it's still a little small there. But so Windows Defender was able to scan the unpacked application to detect it and was able to block it at the time when it required admin rights. So at the time when it required to perform a critical operation, we were able to scan it at a more advanced level and block it. So great, so that's pretty exciting. Shut that down, I don't need that anymore. Okay, let's switch back. So continuing with the same vein, now consider, that was just one example, right? That was just an example of file coming from email. Simple. Let's move on from that. That's not enough for us, right? Files could come in from Skype. Files could come in from any of your P2P clients. Files can come in from the internet. So consider the scenario where one of your developers, let's say somebody you've hired recently, or one of your on-call staff, or they need to download some script, and they actually pull this file from the internet. So the same thing happens. Windows 10 tells Defender this file came in from Skype. And the file, he runs the file, and at this point in time, the script file is obfuscated. So how many of you went to some of the talks given by, I think it was, not Magnus, I think it was, there were a few security talks where they mentioned PowerSploit and PowerShell, and so great. So they gave an example of how the script file could be obfuscated, and the script file could just come down from the internet, and yeah, the current generation anti-malware, the engines can't scan it. I mean, because they can't wait for the file to be pulled down from the internet. There's a trade-off that you need to make between performance and trying to scan the file. But with this additional context, Defender is able to scan de-obfuscated file. Let's actually look at a demo of this. I think it's a really exciting demo. Sorry, just a second. I'm just bringing it to the other screen. And it doesn't want to. Okay, so here's a super simple PowerShell script. So they downloads it from the internet. Yeah, the current generation anti-malware product can detect it. So malware authors will react with some form of obfuscation. They may do, you know what, let me actually kind of split the actual exploit code and split into two strings. This anti-malware engines today, yeah, they can detect it. They will basically emulate, and they'll emulate a certain portion of the existing script, and they can detect this with some good signatures. But then malware authors will react, and then when they will add some form of base64 encoding. And at this point in time, current generation anti-malware products, they can't detect this. Because if they were actually doing base64 encoding and decoding, the performance would suck. It just wouldn't work. There's a trade-off between performance and how much scanning you can do. But let's say that they can detect this. They will just go even further. They will add an XOR encryption on top of this base64 encoding. Game over. At this point in time, no way the current generation anti-malware can detect this stuff. Let's make it even harder. Let's say they even say, you know what, I don't even want this PowerShell script to be on the disk. It just pulls it down from the web, because at this point in time, all this is doing is just invoking this script that's hosted on Pastebin. I mean, they may host it on Pastebin, they may host it on YouTube. You can't block access to these sites. So this example here, I mean, like, great. And let's make it even harder for this new generation anti-malware product, right? They're saying, not even a file. I'm just going to type it into PowerShell. That'd be pretty awesome. That'd be pretty sweet. Let's see. All right, I guess I need to type it out now. Just give me 1 second. I'm just going to switch it over so I can actually see what I'm typing. So I actually just typed in PowerShell, and the PowerShell engine de-obfuscated, pulled this down from the web, and at the time before executing this code, it called the anti-malware engine. So this is local context that was given to us by the operating system, and it allowed the engine, the anti-malware engine, to obtain de-obfuscated code. So they can do any form of obfuscation, but we will get the de-obfuscated stream to the anti-malware engine. And the only signature that we have here is the ICAR signature, and that's oh, I actually looks like I might have network connectivity issues here, but yeah, let me. I'll come back to this demo, I think, when I have network connectivity issues. Okay, I'm going to continue. And so yeah, I showed two examples of how we use the local context provided by the operating system. Can anyone in the audience take a guess on how many such instances of such local context that we have added in Windows Defender and Windows 10? Did we double the number of local contexts that we have over Windows 7? Anybody? Any guesses? And all the blue items are we saw the UAC example. The AMC is the the script-based example that we just saw, any guesses on how many other local contexts that we added? 5 times. So it wasn't 2 times. It wasn't 10 times. We've actually increased the amount of local context 20 times. And I actually want to walk through pretty quickly the type of local context and events that we have added to. So this is the list of events from Windows, and this will be updated. This list will be updated for Windows 10. So you heard a lot of talks about lateral movement. You heard a lot of talks about once an attacker gets into your network, being able to compromise the system and then being able to log into another machine. So we fed all these events to the endpoint security product, to Windows Defender. Windows Defender can now consume all these events. So a Kerberos ticket is changed, Defender is aware of it. A log on, log off is done. The OS has made this context available to AV and Defender products. So this is how the next generation of anti-malware products will function. They will not just be consumed file-based scanning, they will also consume other local context. So if you go back to the example that I started with, knowing that an email came from a certain URL, and then a logon was performed from that machine to a different machine, the endpoint security product will be made aware of all this local context and information. So we have increased, we now are aware, the OS is aware of every single activity going on in the machine. It's pretty obvious. OS is aware of every single activity going on in the machine. We expose that awareness to the endpoint security product. So now the endpoint security product can consume this information and apply the right intelligence on that to make the right security decisions. So that's why we have increased the amount of events by 20 times. And Defender uses this information, stores this information in a secure manner using the persistent store, and uses information to aid its detection. And the Shields Up is our internal component that we call for smartly knowing the risk level of the file and the action and raising the amount of scanning that we do. So this is definitely one of the pillars for next generation anti-malware. Security products are enriched with local context. And of course, you've heard a talk about device guard. If you have the latest hardware and firmware, this context is also exposed by the OS to the endpoint security product so that it can use this information in aiding its detection rules. When an example would be signing and like an expired certificate would be useful to scan for more in depth in this particular case. So the second is enriching your security product with global sensors. Windows runs on about 1 billion machines, and Microsoft has a tool called the malicious software removal tool. How many of you are familiar with the malicious software removal tool? I think most of you are. And that runs on nearly 1 billion machines. So the scanning that we do on that, we are aware of these are our sensors on nearly 1 billion machines. And we have deployed our real-time protection products on nearly 300 million machines. So again, we get this rich, extensive sensor network from these machines. But we went further. We said we also need the context from the largest email and file services and URL filtering services on the web. Well, actually, so you saw the example previously, going back to the previous example, where your VP got this file, and she ran it, and your developer got this file, or the script file, and they all send up the machine profile, the threat profile, the suspicious activity that occurred on the machine, and the persisted context. So today we actually receive over 100 million queries to our cloud service. And this cloud service is geo-distributed and, importantly, privacy and compliance aware. And we're building this out geo-distributed to respect the different compliance needs for the different geos as well. And we can respond to the different machines in less than a second. So that was the sensors in over 1 billion machines. Now the sensors from the different cloud services. So we run one of the Internet Explorer. We actually block over 3 billion bad URLs and phishing URLs. We have a component called Smart Screen and URL Rep. To date, we have blocked 3 billion malware alerts. So this information is fed into the Windows Defender cloud. Second, from Outlook and from Exchange Online, we block 10 million spam blocks per minute. That's 10 million spam blocks per minute. This information, again, is fed into the Windows Defender cloud. So the Windows Defender cloud is your intelligent cloud that provides this vast, extensive global sensors that Windows Defender client makes use of. So when an email comes in and it is caught by one of the spam filters, Defender on every other machine immediately knows that that file was caught by a spam filter. And so Defender is not going to allow it to run on another machine. And that is the vast, extensive global sensor network that we use to combat the advantage, that asymmetric advantage that malware authors have. So going back to the previous example, so the persisted context that your VP opened the file, ran the file, and it ran and gained admin rights. That context is sent to the cloud. And now consider a machine in a totally different geography, say in Australia. A user plugs in the file through USB. We know now the Defender Cloud already is aware that this file ran on a different machine, exhibited malicious behavior. So the moment it is plugged in, the Defender Cloud responds with a block message. So the file is now blocked on this machine even before it runs. And this happens, it can happen instantaneously. And the Defender machine on Windows in Australia knew to call the cloud based on the local context that the OS gave it. It said, file is coming in from USB. USB, yeah, I consider it to be risky. So let me check in with my cloud and see whether the file should be allowed to run or not. And that's how the local context is used again in this place, in the cloud calls. So the Windows Defender Cloud, we have essentially built a vast, interconnected global sensor network. And it allows us to have a global context in the cloud. Our researchers continuously look at this data. They add new machine learning algorithms, and the cloud engine responds back to the clients. And this is what allows us to beat today's malware and shorten that life cycle that malware has. I mean, malware today, they know that the industry reaction time is 8 hours. We have shortened that with our cloud protection. This is our approach to combat the current advantage that malware authors have. And these are some results. So the ZBot family is highly polymorphic. So current signature-based technique does not work. Our cloud comes in, and we have shown that about 56% improvement in the ZBot detection rates. Cinder is another family. We have about a 36% improvement there. And these numbers are a few months old. These numbers change. We track this daily. We track this, and we review this with researchers and analyze where our gaps are and go and address the gaps. I'm going to skip this demo because of the network connectivity issues. I'm going to come back to... So I think the takeaway here is we've added smart cloud calls on Windows Defender clients in Windows 10 to call our cloud and be able to check in with the cloud and get this global context. And of course, our cloud is enriched with context from over 1 billion devices, information from Exchange, IE, and Outlook. So the third section of this talk is how do we actually empower you? How do we optimize security products for the enterprise? So first, we looked at the largest section of attacks that we've been seeing recently on Windows 8 and Windows 8.1 and Windows 7 as well. Obviously, it is the browser. But even in the browser, the attack targets are shifting. It is not in the browser itself. It is not in the core operating system itself or in the applications that ship, components that ship in the operating system. It is actually moving to the applications that ship on the OS. So in the case of IE, it is shifting to the plugins in IE. So Flash and Java were the top targeted plugins in IE. And this is pretty clear why, right? This is because they have the same amount of deployment as IE and any of the other browsers. So, and users don't keep them up to date, and that's why they were being targeted. So an interesting observation here in the first half, the blue and yellow lines, orange lines, show that there was a balanced targeting between Flash and Java. Towards the second half of 2014, over 90% shifted to Flash. Because we actually shipped, this coincides with the feature that we shipped to block out-of-date Java on IE. And the attackers then moved to Flash because Flash was still a target available to them. And this, we use the Defender extensive sensors, the IE extension validation telemetry and feature to actually block this. And we're continuing to make investments here. The following talk is actually all about browser security. So I won't get into more detail here on IE security itself. And so this is one portion of how Windows 10 security is being improved to reduce the risk that it exposes your enterprises to. I'm going to shift gears now and talk about how do we actually manage these security products. So I think you're familiar with Config Manager. How many of you use Config Manager in the room? I think most of you do. So Config Manager will continue to be the default management experience for Windows 10, and SCEP and Windows Defender will be managed by Config Manager. And Microsoft Intune will provide your BYOD management experience. And Operations Manager will provide the Windows Server anti-malware management pack. But over and above this on Windows 10, we know you guys love choices. So we have made Windows Defender fully manageable in Windows 10. This was never the case before. It is from Windows 10 onwards. And it's a vast set of choices. So you have OMA DM for agentless management, PowerShell, WMI v2, command line, and of course GP. So this is actually, I want to emphasize this point here because, so you remember the vast set of local context that is being fed to Defender? You can use that to identify malicious behavior. So if you actually want to look out for behaviors that are interesting in the environment, you can use these WMI management tools to check for that behavior. You want to see an interesting logon event combined with a file arriving on a machine? Yeah, I mean, I think you can put these events together and you can look for that information, that activity on your network. So the second piece is there's always going to be a case when malware gets past your protection mechanisms. And in this case, you will need to clean this advanced malware. So today's standard is to have you create your own CD, USB, and boot your machine into this offline operating system. And it was not just us. It was also, and this requires like 150 meg download, and it's a manual process. You take your USB to that machine. And it was not just us. It was also other AV products which make you do this. So on behalf of the AV industry, I apologize for the current standard. Because it's just painful, right? I mean, you can't actually take a USB, a CD, reboot a machine into an offline OS. With Windows 10, you no longer need this. It's a 2 to 3 MB download, and it's an automated process. Let's actually look at a demo for this. So yeah, so I have a test file which I'll actually just run in. So Defender actually blocked this file, and so now it's going to start to remediate this file, and give it a few, give it a minute or so, because it actually will try to remediate the file, and because it's advanced, well, it's supposed to simulate advanced malware. It'll show you the prompt, and then we'll walk through this, and just give it a minute while it actually runs. And the final, the notification that you'll see on the bottom right of the screen is still work in progress. While while that notification comes up, I'm going to try and see if I can get the other demo going. Yeah, so in Windows 10, the notifications will actually show up here once Defender is tried to remediate and it is unable to remediate, and it'll ask you to go into the offline OS. Oh, yeah, go ahead.
Rich context, some of these, if that client will be updated to take advantage of these, or if it will work hand in hand with Defender.
Yeah, that's a great question. So with Windows 10, you will get these capabilities. So when System Center R2 releases next week, that is going to support Windows 10 as well. So you won't get these rich local context on Windows 8.1 and Windows 7, but you will get it when you have a Windows 10 endpoint. Does that? Oh, great. Yeah. So, I want to clarify that confusion there. So, System Center Endpoint Protection and Windows Defender on Windows 10 are identical. There is no difference. It is just we are just rebranding the platform and engine underneath. That's a great question. I think we always get that question.
So why run one versus the other?
No, so you would just, on Windows 10, you would just run one.
So is System Center just going away? Defender on Windows? What's the enterprise?
Yeah, okay. Let me go back to that slide. That's a great question. I think, sorry, we always get that question about this, and I want to clarify. I want to spend a minute or so. Okay, so sorry. Here's the notification about, and again, this is work in progress. This is not the final notification. And I'll actually load it, run it from here. It's weird. Oh, come on. Sorry, this is they're using one of the latest builds. I guess this is where you gotta be very. Okay, well that loads. So I think, sorry, you had a question about that. I'm going to go back a few slides just to answer your question on that. So Config Manager will be the default management experience for anti-malware, the Microsoft anti-malware product. So under the covers, we just use Windows Defender. And Windows Defender on SCEP, System Center Endpoint Protection, on Windows 10 is the same. We just need to we are rebranding it. We just applying a UI layer and the manageability, the full manageability layer to interface with Config Manager when you deploy SCEP. Does that answer your?
So on Windows 10 for the enterprise, I'm still going to install SCEP instead of just using the built-in.
Yeah, when you actually deploy SCEP, what it does, it tells Windows Defender to talk to Config Manager in the right way. That's all it does. It doesn't replace it. So does that answer?
Will that be updated then? Will that just come with the System Center update then?
Yes, yes, yeah. It's seamless. There's no change. There's no change from a SCCM standpoint. Yeah.
So what about SCCM new on a Windows 8 or Windows 7 platform? Are there any additional features that are not counting 10? Or like what is not 10 or not? Is there anything coming new SCEP for Windows 8?
Yes, we do add features down level for SCEP, but they're definitely not as advanced as what we do on Windows 10.
Please use the microphones. This session is being recorded and others will need to hear the questions.
You have 1 billion sensors that you spoke about. Some of that information should be able to be used to protect our Windows 7 and 8.1 clients, right?
Yes, and yeah, so some of the capabilities are available down level, even especially for that extensive global sensors. However, knowing when to talk to the cloud, which is based on the local context, that is unavailable on the down level OS. So we are far more limited in terms of what we can talk to the cloud. So for example, a good example is the admin elevation example. We don't have that context on down level. So at that point, we just don't know to talk to the cloud. Yeah.
Is there any documentation on the events that will be available also for third-party security products?
Can you repeat it?
Is there or will there be any available documentation on the events that will
yes.
be available?
Yeah, definitely. So, yeah, I was addressing this talk towards like a IT pro audience. For AV companies, there's the Microsoft Virus Initiative, MVI program, and MVI partners receive these events and the documentation to get access to all these events.
I have a question.
Yeah, go ahead.
So all these informations are available in the cloud, yeah. So are there any like third-party integrations like APIs? So for example, if you're doing reverse malware analysis and you see some binaries that are malicious, we can hash them and then send them up to you guys' cloud and have it to check as well?
Yes, come talk to me after the talk.
Okay.
So, so the other scenario. So with Windows 10, we've heard IT pros talk about BYOD and the challenge with BYOD. And today, you need to download a 25 meg endpoint agent and then download another 125 meg signature as well. With Windows 10, with OMA DM and Defender Inbox, you don't need this endpoint agent. And if the user is already running Windows 10, you also don't need to download the definitions which have already been there on the machine. So just imagine having your end user enroll their home bot machine on their home connection. They don't need to download this additional 150 megs on their home machines and home network. So, yeah, go ahead. Oh, sorry. Thanks. Yeah, so that was the previous comment. So moving from BYOD, the other things we heard customers ask about is, hey, what about my servers? So you protected my BYOD, my servers are also unprotected now. And so what about my servers? So with Windows Server vNext, Defender is inbox. And Defender is going to be called Windows Server Anti-Malware on the server environment. So it'll be available by default and it'll be on by default, and it is optimized for these server roles, and it is available in all these different SKUs. And I think I really want to emphasize the point about the optimized for the different server roles. Because we always hear this feedback that, hey, running anti-malware on my server impacts performance, and I have different issues with these different server roles, etc. So we worked quite a bit with the different roles teams and diligently improved performance. And these graphs actually show the difference in performance with Defender on and Defender off. And there's hardly any difference. We went further. We actually continue to monitor these performance from real-world systems and adjust and tune this performance. So Windows 10 gathers performance data, which allows us to close a loop. We gather the data, improve automatically, and push down the right updates to make sure Defender does not impact your server performance. The second question we get is, hey, I don't want Defender scanning my Exchange logs or my IIS web logs. So what did we do? We built in this feature. Of course, it's configurable. You can turn it off, and you can add exclusions and remove exclusions. We built this feature called automatic exclusions. So along with definition updates, along with the signature updates, we also push down the right exclusions for your role on the machine and apply them on where the roles are enabled. So if a machine having IIS, we apply the exclusions that are relevant for IIS. On machines that have Exchange, we apply the exclusions that are applicable for Exchange, which is a pretty cool feature. And we can now update this along with our signature update. So every 8 hours, we can actually update it. And of course, you as Yeti Pro and admin, you can configure and add. The changes that you make are additive. So yeah, I want to go back to this point here. So I think I want to use this to clarify the question that came up earlier about SCEP and Defender. So Defender is manageable inbox. SCEP is just a UI layer on Windows 10 above Windows Defender. So when you actually push out SCEP, you're just basically telling Defender, hey, config manager is your management console, talk to it. That's all you're doing. And you're just basically changing it just changes some reg keys, etc., to tell Defender where to talk to. So it's the same product on Windows 10. And the management agents, yeah, I think you have System Center, SCOM, Intune, all of them can manage Defender. So we started with the current state, and we said that today's OS 7, 8 do not expose sufficient local context. We saw examples. We saw how we've increased the amount of local context 20 times on Windows 10. And these are some examples of how Defender actually uses local context. And we saw how malware authors have an asymmetric advantage. So Defender, using these extensive global sensors, is able to overcome this advantage because be able to adjust and circle back in a closed loop in less than 8 hours, significantly less than 8 hours. And security products today are not optimized for the enterprise. Defender, we saw the example of the cleaning advanced malware, being ready for BYOD, being on Windows Server anti-malware, and having the automatic exclusions feature, all examples of how we've optimized for the enterprise. And additionally, we also the vast array of manageability options, being able to query Defender for behavioral analysis. So these are examples of how we've enabled, made Defender optimized for the enterprise. So my ask today to you is, so let's actually together beat malware, deploy Windows 10, enjoy the rich local context. Defender on Windows 10 has an extensive global sensors. And finally, Defender is optimized for the enterprise. That's it. Thanks.